Hello there, class. This is Mr. Brooks here. This will be the first of a series of lesson videos that will be accessible for you over the period of this semester. They will be on my website as well as posted on Google Classroom, so you'll have multiple ways of getting these. These videos are to help you if you're absent in the day and you need to come back and learn the lesson that we went over in class, or if you want to come and review to get ready for a test, or any sort of homework as you're working through that and you need to remember how to do something. This acts as a resource for you to be able to access as you're working through. And furthermore, if your parents are ever wanting to help you, or if you are a parent watching this and you want to assist your child as they are working through pre-algebra, this is a resource for you as well to be able to work through. So, today's lesson that we're going to be going through is a form of a transformation. It's a transformation. We've been talking about transformations over the past week almost now. But today I want to start with this. So, a couple years ago, I learned how to solve a Rubik's Cube. Notice I have a normal Rubik's Cube. It turns just like any sort of Rubik's Cube would. The only thing I've done is I've taken a piece of paper, and notice I've glued it on to just one of the squares on one of these sides. You see that? I glued just a piece of paper, and I drew a triangle on this paper. In class, what I would have done is given this to the students to be able to shuffle up and scramble. And then we go through the process of solving the Rubik's Cube, right? So, looking kind of what we have here, we go through the process of actually solving it. And in class, I would explain kind of a little bit about what I'm doing. Essentially, what I'm doing is I start by making, notice there's this cross on one side. It doesn't particularly matter. But on the other corresponding sides around it, I'm matching up those edge pieces to the other centers. Then, I do a series of moves and algorithms to allow me to match up the corner pieces to where they need to go. And there's the final one. And then you kind of, continue to work through the process. You get to a place where you're almost done with the cube. There we go. Right? And now the last sort of step here, right? And so, there we go. And then finally, the last of the corner pieces. And the entire cube is solved. Now, what I want you to notice here, as we solved this cube, we had to do a series of transformations. And here's what I mean by that. A transformation, like we've described and defined before, is a process that we do to a figure, or a shape, or some sort of figure that we can work with, and we do something to it to alter where it is or what it looks like. In the case of a Rubik's Cube, when you first scramble it up, you have the pre-image, or the original picture of what you wanted to see. And then we had to rotate these sides in such a way that it becomes solved. So, one of the several different transformations is called a rotation, okay? And a rotation is where we have a center spot where other parts are going to spin around, right? And when I turn, notice it spins from the center. You see, the center never really moves. It's the blocks around the center. So if I were to turn, the triangle that was up here at the top left has now moved to the top right. And it can rotate down to the bottom right and to the bottom left. So that's something to consider. Right, moving forward into this topic of rotations is this conversation that we have about where our figure will move after I rotate. one more piece to consider, and then we'll move into these notes, is how many times I rotate and what direction I rotate in, right? Because when I rotate it just once, I'm rotating it 90 degrees, clockwise. And we'll get into that a little bit, versus 90 degrees counterclockwise. So this is just kind of a way to introduce this topic, and I want to now dig a little deeper and start kind of going over some notes here over this process of rotation. So the goal of today is to be able to rotate figures in a coordinate plane, right? What are some other words for coordinate plane that we've seen before, right? What are some other terms that we've seen when we're talking about a coordinate plane? Well, we've seen the word graph, right? We've seen the word graph. We've seen the word grid, right? We've even seen the word, I don't know, you might have even seen Euclid, that name pop up. Just some different things that might elicit what we're talking about here when we have the x and y axes, right? We have a coordinate plane. And now we're going to be able to rotate shapes around it. In order for you guys to be successful with this lesson, I need you to be able to identify that a rotation is happening, then be able to find the coordinates of a figure that's been rotated around the origin. Remember, the origin is the point 0, 0. And then finally, use those coordinates to rotate a figure about the origin. Okay, so key idea here that we're talking about. To define what we're saying, a rotation, it's also called a turn. It is a transformation, right? It is some process that we're doing to a figure where it is rotated around a fixed point. I'm going to kind of squiggle this one. A fixed point. And that fixed point is called the center of rotation. So, here's what I did. Notice there's a little diagram here that's very helpful. I made a tiny little shape here that should fit right there. Just like so. Right? And it's red just so that way you can distinguish it from the rest of the paper. Now, the shape that we have, it's kind of like this trapezoid almost. It's a four-sided shape. And when I rotate it, there's that center of rotation. You see that? It's this little dot right down here. It's called the center of rotation. It's the place where the shape that we have, this figure, will rotate from. Then we do the turn, right? So suppose we take this figure and we just rotate it. Bam! You see that? We can rotate this shape around. Just like so. Alright. Now keeping that in place, another interesting and important piece to talk about, we've talked about the center of rotation. It's where the figure is being rotated around. But then there's this angle of rotation. Okay? Now, talk amongst yourselves, if you guys are working together, what are some different angles that we have, that we've seen before? Well, here's a triangle, and I'm just going to put a little angle in there. Remember, if I have that right angle, that's the same thing as 90 degrees. So we have 90 degrees. And then if you ever use one of those protractors, right, where it has all the different numbers up here for you to use, well, a protractor is 180 degrees, right? A straight line is 180 degrees. And then we'll even throw one more in, right? If we have 90 degrees and we have 180 degrees, what's 180 plus 90? We're going to get 0. 8 plus 9 is 17. We're going to get 270 degrees as well. So these are important numbers because if I have a circle if I have a circle, kind of like this clock, right? How many degrees is a circle? Well, it's 360 degrees, all the way around. So what's neat is 90 degrees is 1/4 of a circle, right? If we take 360 and divide it by 4, we get 90. And each of these, right, 90 degrees, 180 degrees, and 270 degrees are all of the quarters, right, of the clock, or of a circle. It goes from 90 to 180 to 270 to 360. So when we're turning it, like we did with this figure over here, I rotated the figure 90 degrees. And let's go another quarter, right? Let's go from 90 to 180. It'll end up down here. And then we'll do it once more, right? Let's reflect it, or rotate it one more time. That's 270 degrees, right? So we have 90, 180, 270, and back up here to 360, right? And these have all degrees. One more conversation to have. When we're rotating, we either go clockwise or counterclockwise. If you've ever played the card game Uno, or any other sort of card game like Exploding Kittens or something like that, where you have to go in an order of people, right? Think about a clock and the way that it moves. When the clock moves, if you're going around towards the right, that's clockwise, right? Going around towards the right is clockwise. And if I'm going the opposite direction, going more towards the left, right, that's counterclockwise. So when we're rotating each of these 90, 80, 170 degrees around, we need to keep in mind whether we're rotating clockwise or if we're rotating counterclockwise. And that will matter. Okay. Now that we've kind of explained a lot of these vocabulary terms and key ideas, let's start with a problem here. Example number 1 says this: you must rotate the puzzle piece given here, so here's my puzzle piece, 270 degrees clockwise, about point P, to fit into a puzzle. Which piece, A, B, C, or D, fits the puzzle as shown? So, kind of like what I had before, here's the puzzle piece that we're talking about, right? And I kind of added a little piece here that connects it to point P, right? So here's the puzzle piece that I have, and we need to rotate it 270 degrees clockwise. So I'm going to underline those important things: 270 degrees and clockwise. So, which way will the puzzle piece turn? Is it going to go right, or is it going to go left? Well, it's going to go right, because it's clockwise. And now, how many times am I going to rotate it? Well, 90 degrees is a quarter, so 180 degrees is half, 270 degrees is 3 times. I'm going to rotate it around 3 times. So, here's time number 1. Oh, let me see if I can get a little bit better picture of this. So, time number 1, there's 90 degrees, right? 180 degrees, and then one more time, 270 degrees. So, this is the shape that we end up with for our puzzle piece. Now we answer the question: which piece fits what we have? Is it A, B, C, or D? Well, It's C, right? We've rotated it 270 degrees clockwise, and the shape we ended up with was C. Let's try another one. It's a little harder to see just because it says blue and red. So here's what I'm going to assume here. This is me just kind of putting this in place. I'm going to say that this left figure here is the blue one, and the figure on the top right, that's going to be the red one. And same sort of thing here. This is going to be blue, the filled in one's going to be blue, and this one's going to be red. Okay. So, tell whether the blue figure, this triangle we have, is a rotation around the origin. Remember, the origin is 0, 0. So, is this a rotation? Well, I would say yes. Because if I take this triangle, right, like I kind of did before with the motion, and I rotated it around, well, this bottom part's going to end up at the top, and then the slant is going to almost be mirrored over here. What about number 2? Is this a rotation around the origin? Here's the origin again. Well, what would it look like if I rotated it? It would go here, then it would go here, and then it would go here. Yeah, it would go here. Does that line up with what we have for the red? It doesn't fit perfectly, so no, it's not. 1 is a rotation, right? We're taking this triangle and we're rotating it around. But in this case, if we were to rotate the square any sort of degrees, it's not going to turn into the red. This is a translation, right? It's a slide, not a rotation. All right. So now we get into some of the algebra ideas, okay? This is the mathematical representations here of what we're talking about, because it's one thing to do it very visually with some graphs, but we're not always going to have the time to draw everything out and then do all of these math processes. So what's another way we can look at this process? We looked at a visual idea of what's happening here, but what about a numerical way? Well, we can use coordinate rules to find the coordinates of a point after a rotation of 90, 180, or 270 degrees. So this, I'm going to say this right now, this is the manual. You know how like when you get a new toy or like a new sort of resource, like, I don't know, I just got like a popcorn maker over Christmas and I had to read the manual to make sure I didn't, burn down my house when I'm using this. I think that's supposed to be an E. Anyway, so when I'm learning how to do something, there's a manual. It's like an instruction guide that I can use to go through and solve this problem, right? So, if I go 90 degrees clockwise or 270 degrees counterclockwise, xy goes to y negative 1. So, here's an example. Let's say I had the point 1, 2, okay? I'm going to flip y to be the first number. So remember, if you need to write this down, please label it. It's very helpful to label these. Y will become the first number. So I'm going to get 2, right? 2 is going to be the first number. Then x becomes negative, right? So if I have positive 1, it becomes negative 1. Y, negative x. Okay? And that's if we're rotating 90 degrees clockwise or 270 degrees counterclockwise, right? Going around left, 3/4 the way. Let's look at the second one. 90 degrees counterclockwise or 270 degrees clockwise. We do a very similar thing, except this time the y becomes negative instead of the x. So let's use that same number we just did. We had 1, 2 was a coordinate, okay? Well, we're going to swap them. So we're going to have 2, 1. But this time, the y becomes negative, right? If this is x and that's y, we're going to have negative y and positive x. So instead of 2, we have negative 2, and 1 stays the same, but it goes into the swapped spot. And that's if we're going 90 degrees counterclockwise or 270 degrees clockwise. Last one. If we're just going 180 degrees, if it's 180 degrees, we keep x and y the same, except they both become negative. Okay, so if I have 1, 2, it becomes negative 1, negative 2. The numbers just become negatives. Okay, let's look at what we have. The vertices of a trapezoid, a four-sided shape that looks a little bit like this, like a flipped over pie. They are negative 4, 2, negative 3, 4, negative 1, 4, negative 1, 2. So we have 4 coordinates for each of these 4 corners. Rotate, so we're going to be rotating here, 180 degrees around the origin, like we've done before. What are the coordinates of the image? In other words, what are the new w prime, x prime, y prime, z prime? What are the new coordinates when I rotate this trapezoid? So, let's go back to the manual. 180 degrees. Which of these 3 rules are we going to use? Are we going to use rule number 1, rule number 2, or rule number 3? Well, we're going to use rule number 3, aren't we? We're going to just make all these numbers negative versions of themselves. So, if we have w is negative 4, 2, I'm going to draw this arrow and say 180 degrees, right, because we're rotating 180 degrees. What is that new coordinate going to look like? Well, what is negative 4? Well, that's going to be positive 4. Double negative is a positive. And then we get negative 2, all right? So we got double negative goes to positive, positive 4, negative 2. And that's our new w coordinate. Let's try x. So x we have is negative 3, 4. We do the 180 degrees, right? We use that step that we talked about. So x prime is going to look like negative 3, negative 4, which, like we just did, that goes to positive. So we have positive 3, negative 4. Let's try y. We have y is negative 1, 4. Transformation. Y prime, the new y that we're going to look at, has the negative 1, negative 4, right? We're just making both the x and the y negative. And like we've seen before, it'll just become positive. So we get positive 1, negative 4. And then the last one, z. Z is negative 1, 2. So, 180 degrees, z prime is negative negative 1, then the negative 2. And again, double negative is a positive, 1, negative 2. And these are our new coordinates. Alright, last problem. The vertices of a rectangle, and here it gives us the rectangle, which is nice. We have negative 3, negative 3, so A is at negative 3, negative 3. B is 1, negative 3. C is 1, negative 5. And D is negative 3, negative 5. Rotate, so we're going to be rotating here, the rectangle 90 degrees clockwise around the origin, right? So if it says around the origin, that's where we're going to rotate from. There's the origin, 0, 0. And then, once we rotate it and reflect it in the y-axis, we need to figure out the rotation. Then we reflect it on the y-axis. There's the y-axis. Here's the x-axis, right? The y-axis is the up and down. So, what are the coordinates of the image? Okay, so let's break this apart. First, we need to rotate this rectangle. Then we need to just reflect it, like we've done before. So, going back to our rules, it said 90 degrees clockwise. Are we going to use rule number 1, rule number 2, or rule number 3? We're going to use rule number 1, 90 degrees clockwise. And what did that say? It said swap the y and the x and make the x negative. So swap the x and y, make the x negative. So I'm going to write this kind of off to the side. Swap x and y, then make x negative. That's the rule. Swap x and y, then make x negative. So, let's start with A. A is negative 3, negative 3. We're going to swap x and y. Well, thankfully it's the same number, so that's helpful. Then make x negative, right? There's x and there's y. So when we do the rotation, 90 degrees clockwise, right, going around to the right side like Uno, we're going to swap x and y. So negative 3, negative 3. It's the same number, so that's nice. And then we make this x positive, right? It's the negative version of x. So it's negative, negative 3. Double negative, well, that's a positive. So we have negative 3, positive 3. And that's A prime. And if we graph that, negative 3, 3. So negative 3 on here on the graph. 1, 2, 3. Positive 3. 1, 2, 3. There's A prime right up here. All right, let's go to B. B, we have 1, negative 3. So 1, negative 3. We're doing the process, right? We're doing the rotation. So we're going to have them swap. So 1 and negative 3 are going to swap. And then 1, since that's the x number, 1 is going to become negative. So we're going to have negative 3, negative 1. And that's going to be B prime. So, negative 3, negative 1. There's B prime. Let's do C. C gives us 1, negative 5. Swap, make the x negative. So we're going to get negative 5, right? That's swap. And then 1 becomes negative. So that's C prime. negative 5, negative 1, 2, 3, 4, negative 5, negative 1. So there's C prime. And then finally, D prime, right? We need to find D prime. So D is given by negative 3, negative 5. Swap, make the x negative. So we're going to get negative 5, negative, negative 3. Double negative is a positive, negative 5, positive 3. And that's going to give us D prime. So, negative 5, 2, 3, 4, negative 5, 1, 2, 3. There's D prime. So, I'm going to kind of put some dotted lines here because we're not done yet. We're almost there, but we're so close. This is when I rotated, notice I rotated around the center, around the origin, the center of rotation, right? Over 90 degrees to the right, right? I went zoom 90 degrees to the right. And then it says, and then reflect it in the y-axis. The y-axis is this axis, and like we've been working on, when we reflect on the y-axis, we need to look at the distance from the y-axis of each of these points. So let's just start with A. What is the distance of A prime from the y-axis? 1, 2, 3 away. And we're not moving up or down here. We're worried about the distance from the axis. So if it's left 3, the reflection is the opposite direction, but the same distance. So that's going to be our actual reflected A prime. Now let's look at B. How far away is B prime from the y-axis? 1, 2, 3. It's 3 away. I'll zoom in here just a little bit more so you can see. There we go. All right. The distance of B prime from the y-axis. 1, 2, 3. It's 3 away on the left. It's going left, right? So when we go and reflect it on the y-axis, we need to go the opposite direction. So we go 1, 2, 3. B prime. Let's look at C. How far away is C prime from the y-axis? 1, 2, 3, 4, 5. So it's 5 away on the left. It's 5 away on the left. So now we need to go 1, 2, 3, 4, 5 to the right. And we're keeping it all in that same line here at negative 1, y equals negative, y equals negative 1. But we keep the distance the same in the opposite direction. And last, let's look at D prime. How far away is D prime? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. D prime. It's just the distance away from the y-axis. So our final picture here is right here. A prime, B prime, C prime, D prime. So what we have now is this final image, this final figure, right? We started with the pre-image, and we rotated 90 degrees clockwise. We rotated towards the right, and then we reflected on the y-axis. So our final result here, right, we're going to have to look at these coordinates. Well, A, where is A at? We have 1, 2, 3, so A prime is 3, and then how high up is that? Right? What is the y-coordinate? Well, that's just 3. B prime, our final B prime, is 3 to the right, and then 1 down, so it's going to be 3, negative 1. C prime, well, we have 1, 2, 3, 4, 5, and then down 1, so negative 1. right, down 1. And then D is 1, 2, 3, 4, 5, 1, 2, 3. So D prime is going to be 5, 3. And that's our final result, right? Because now, there we go, just making sure I can focus a little bit. Because now, after all of that work, we've rotated 90 degrees and then reflected on the y-axis to give us our final coordinates of our image, right? This is our image. Thank you guys very much for watching. I hope that this is supportive and helpful as you guys are working through homework or IXLs and getting ready for any exams. If you need to review, or if you're just absent and you need to make sure you're caught up with what's going on, this resource is available for you. Make sure that you're looking over those rules, right, that you need to know, those algebra rules for rotations, and think about whether you're going clockwise or you're going counterclockwise. It'll be very helpful. Thank you guys, and I hope you have a great rest of your day.